ground fault circuit interrupter, or GFCI, protects against ground faults. These are situations where electrical current flows unintentionally through the ground wire instead of the intended path. A GFCI trips the circuit when it detects a difference in current between the hot and neutral wires. A ground fault circuit interrupter with equipment protection, or GFCPE, provides the same protection as a GFCI, but adds an additional level of protection against equipment leaks. A GFCPE continuously monitors the current flow in the equipment and trips the circuit if it detects a fault. For water immersion heaters and horse ponds, GFCPE is strongly recommended. Water immersion heaters present a higher risk of ground faults, as water can conduct electricity. In the event of a fault, a GFCPE can protect against electrical shock to both animals and humans. It can also prevent equipment damage and fires. Furthermore, a GFCPE ensures continuous operation of the heaters, as it does not trip due to excessive current draw from the heaters. There are some exceptions to this recommendation. Firstly, if the heaters are permanently installed and submerged in water, a GFCI can be used as a substitute for a GFCPE. Secondly, if the heaters are used in areas with limited access to water, such as heated water buckets or wash stalls, a GFCI may be sufficient. It is important to take additional precautions. Firstly, install the heaters according to the manufacturer's instructions. Secondly, keep water levels within the specified range. Thirdly, use a properly grounded power source. Fourthly, inspect the heaters and cords regularly for any damage. A ground fault is an unintentional electrical path between a source of current and ground. This can occur when insulation fails, allowing current to flow through unintended paths like metal enclosures or even a person touching a live wire. Ground fault circuit interrupters are designed to quickly detect and interrupt these ground faults, minimizing the risk of electrical shock and fire. GFCIs work by monitoring the current flowing in hot and neutral wires of a circuit. In a properly functioning circuit, the current flowing through these wires should be equal. If a ground fault occurs, some of the current will leak to ground, creating an imbalance between the hot and neutral wires. The GFCI detects this imbalance and quickly trips the circuit, cutting off the flow of electricity. GFCIs are typically required in areas where water is present, such as bathrooms, kitchens, and outdoor outlets. This is because water significantly increases the risk of electrical shock. GFCPEs offer an enhanced level of protection compared to GFCIs. In addition to detecting ground faults, GFCPEs also monitor the equipment connected to the circuit for insulation breakdown and other potential problems. This provides an early warning of equipment failures and can help prevent fires and equipment damage. GFCPEs are often used in industrial and commercial settings where equipment reliability is critical. The choice between GFCI and GFCPE depends on the specific application and the level of protection required. In general, GFCPEs are recommended for situations where equipment failure could pose a significant safety hazard or cause substantial financial losses. When installing either a GFCI or GFCPE, it is crucial to follow the manufacturer's instructions carefully. Improper installation can compromise the effectiveness of the device and may even create a safety hazard. It is also important to test the device regularly to ensure that it is functioning properly. Most GFCIs and GFCPEs have a test button that can be used to simulate a ground fault and verify that the device is tripping as intended. Regular testing is essential to ensure that the device will protect you in the event of a real ground fault. In addition to GFCIs and GFCPEs, there are other safety measures that can be taken to reduce the risk of electrical shock and fire. These include using properly grounded equipment, avoiding the use of extension cords, and keeping electrical equipment away from water. It is also important to have your electrical system inspected regularly by a qualified electrician. A thorough inspection can identify potential problems and ensure that your electrical system is safe and up to code. Water immersion heaters, commonly used in horse barns to prevent water from freezing, present unique electrical safety challenges. These heaters are often submerged in water, creating a direct path for electrical current to leak to ground. If a ground fault occurs, the water itself can become energized, posing a significant shock hazard to both animals and humans. For this reason, it is essential to use either a GFCI or GFCPE on all circuits that supply power to water immersion heaters. As mentioned earlier, GFCPEs offer an enhanced level of protection compared to GFCIs, making them the preferred choice for water immersion heaters. In addition to detecting ground faults, GFCPEs also monitor the heater for insulation breakdown and other potential problems. This can help prevent the heater from becoming a shock hazard. When selecting a water immersion heater, it is important to choose a model that is specifically designed for use in animal environments. These heaters are typically constructed with durable materials and are designed to withstand the harsh conditions found in horse barns. It is also important to follow the manufacturer's instructions carefully when installing and using the heater. Never attempt to modify the heater in any way, as this could create a safety hazard. Regularly inspect the heater and its cord for any signs of damage. If you notice any damage, such as cracks, frayed wires, or loose connections, immediately disconnect the heater from the power source and replace it. Never use a damaged heater, as it could pose a serious shock hazard. When using water immersion heaters, it is important to keep the water level within the specified range. If the water level is too low, the heater may overheat and cause a fire. If the water level is too high, the heater may become submerged, increasing the risk of electrical shock. Always use a properly grounded power source for water immersion heaters. Never use an ungrounded outlet or an extension cord that is not properly grounded. An ungrounded power source can increase the risk of electrical shock. Keep the area around the water immersion heater clean and dry. Avoid storing flammable materials near the heater. A fire can easily start if flammable materials come into contact with the heater. In addition to electrical safety, there are other safety considerations to keep in mind when using water immersion heaters. For example, it is important to protect the heater from damage caused by animals. Horses may chew on the heater cord or knock the heater over, causing damage or injury. To prevent this, consider using a heater with a protective cover or placing the heater in an area that is inaccessible to animals. It is also important to monitor the water temperature regularly to ensure that it is not too hot. Hot water can scald animals and cause injury. Use a thermometer to check the water temperature regularly and adjust the heater settings as needed. Consider using a thermostatically controlled heater that will automatically maintain the water temperature at a safe level. By following these safety precautions, you can minimize the risk of electrical shock, fire, and other hazards associated with water immersion heaters. Remember, electrical safety is essential for protecting both animals and humans. Ground fault protection is crucial for any electrical circuit near water.